myself K. Bhuvan. Currently, I am pursuing my bachelor's in Srinivasa Ramanujan Institute of Technology in Civil Engineering. Today, I am going to explain a problem in numerical and statistical methods. What is Newton's interpolation method? The problem I am going to explain is based on this method. Newton's interpolation method is a numerical technique used to find the value of a function, for example, population, temperature, etc., between given data points. Why we use it? To estimate the missing data between known values, interpolation. To predict future or past values, extrapolation. The population of the town in the decimal census was given below. Examine the population in the year 1895 and 1925. Here the data given is in the year 1891 the population is 46, and in the year 1901 the population is 66, in the year 1911 the population is 8, and in the year 1921 the population is 93. In the year 1931 the population is 101. We need to determine the population in the year 1895. Here we can see the 1895 value is at the starting of the table. So we use Newton's forward interpolation method. Let x equal to 1895. It is given in the table. It is at the start of the table. So we use Newton's forward interpolation formula. The forward difference table. Here x values and y values are there, and delta y, delta square y, delta cube y, delta power 4y. How we can determine delta y? By difference of yn minus 1, like y2 minus y1, y1 minus y0. We can find delta y. Here 66 minus 46 is 20, 81 minus 66 is 15, 93 minus 81 is 12, 101 minus 93 is 8. To determine delta square y, we need to find a difference between 15 minus 20 is minus 5, 12 minus 5, 15 is minus 3, 8 minus 12 is minus 4. Likewise, we can find delta cube y and delta power 4y. The formula we used in Newton's forward difference table is f of x equal to f of x naught plus p into delta f of x naught plus p into p minus 1 by 2 factorial into delta square into f of x naught plus p into p minus 1 into p minus 2 by 3 factorial into delta cube f of x naught, and so on. P equals to x minus x naught by h. Here x is the given value and x naught is the first value, first x value, by h is the height difference. Here given below, x naught, y naught are first x comma y values, h is interval difference. By calculating this, we get 0.4 p value. By substituting the values in the formula, we can determine the population in the year 1895, that is 54.85. Let x equal to 1925. It is at the end of the table. So we use Newton's backward interpolation formula. It is at the end of the table, so we use Newton's backward. y1 means last y value, x1 means xn means last x value. P equal to x minus xn by h. P equal to 1925 minus 1931 by 10. We can get minus 0.6. And the formula we used for Newton backwards is f of x equal to f of xn plus p del f of xn plus p into p plus 1 by 2 factorial del square f of xn plus p into p plus 1 p plus 2 by 3 factorial into del cube f of xn, plus and so on. By substituting the values in the formula, we can determine the population in the year 1925, and that is 96.84. By Thank you so much for your time, ma'am.